Standard 4.5, finding the areas of quadrilaterals using triangles, law of sines, law of cosines. Alright, so if we take a look at our diagram, we have a quadrilateral, a four-sided figure, and our job is to find the area. We don't have a lot of information, but what we can do is divide this quadrilateral into two triangles. And now we have a little bit more that can help us. So let's consider our triangles. We have a yellow triangle in here. Change the thickness of that highlighter a little bit. So we have a yellow triangle, and we have a blue triangle here. And let's separate our triangles out. So our yellow triangle has, that's triangle ADB, has a 100-degree angle and side lengths of 5 and 6. That's our yellow triangle here. And our blue triangle, triangle DCB, has sides 8 and 7. And that's all the information we have about that particular triangle. And let's make that our blue triangle. Okay. So we have enough information to find the area of our yellow triangle. To find the area of a triangle, you need two sides and the included angle. And so the area of this yellow triangle is going to be 1/2 times a side times the side times the sine of the included angle. And so the area of that triangle, if we put it on our calculators, 0.5 times 5 times 6 times sine of 100, the area is about 14.77. And now if we can find the area of the blue triangle, then we can add the two areas up and find the total area. So to find the area of the blue triangle, we need to know the measure of angle C. But we don't have enough information to find the measure of angle C. However, if we find side DB, let's call that little a, because it's across from angle A here. If you find little a, which is right here in our diagram, so it's the overlapping side. If you find little a in the yellow triangle, we can transfer that measurement to little a in our blue triangle, and then we have three sides in a triangle, and that's enough information to use law of cosines to find angle C. So let's find side A. So notice in the yellow triangle we don't have any matches. We have an angle but not the side across from it, or a side but not the angle across from it. So we're going to have to use law of cosines. We'll use the version that starts out as a squared. A squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A, 100 degrees. If we put that all in our calculator, we get a squared is equal to 71.4 something, and if we take the square root of that, a is approximately 8.45. So let's transfer that measure into our triangles, our main picture. 8.45 in the yellow triangle, which is 8.45 in the blue triangle. Now we can use the information in the blue triangle to find angle C. So little a is across from angle C, so we'll start out with little a squared equals the other two sides, so squared, so 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of angle C. Alright, let's square 8.45. add the 64 and the 49 together and get 113 minus 112 cosine C. Now don't make the mistake of subtracting 112 from 113. You actually need to subtract 113 from both sides of our equation. And when we do that, 71.4025 minus 113, we get negative 41.5975 equals negative 112 cosine C. Now divide both sides by negative 112. Equals cosine C. And if we do that division, we get cosine C is approximately 0.37. Use inverse cosine to find angle C. Cosine's positive in quadrants 1 and 4, but a quadrant 4 angle measure wouldn't make sense in a triangle, so we're only looking at the quadrant 1 angle, 68.2 degrees. So angle C is 68.2 degrees approximately. So let's put that measurement back in our triangle, 68.2 degrees. Now we have enough information to find the area of this blue triangle. So 1/2 times the side times the side times the sine of the included angle. So our area would be 1/2 times 8 times 7 times the sine of 68.2, and that's approximately 26. And so the area of the quadrilateral would be the sum of the areas of the yellow and blue triangles, 14.77 and 26, and that ends up being 40.77. And that's the area of the quadrilateral. Now every problem is a little different, but the main trick, the main strategy here is to divide the quadrilateral into two triangles. Find the length of the diagonal because it's common to both triangles, and use that to find whatever pieces you need to in order to calculate the areas of the quadrilateral. That is standard 4.5, finding the area of quadrilaterals.